Hello everyone, welcome to the Learning Royal. Today, we'll be looking at the proof for Heron's formula. Well, all there is to proofs is logic, and that logic is just used to make even more logic that makes logical sense. If you didn't get that, well, too bad for you. You're either getting hit by a cricket bat or a baseball bat. Your choice. Um, but something even better to hit you with is the chapel. Anyway, let's carry on with what we're doing here with the Heron's formula, and uh, let's try to prove it. So here we have a triangle on the screen, which has sides A, B, and C, and the angle opposite to the side is named by its corresponding letter. So a lowercase a for the side length, it would be a capital A for the angle, and we shall continue this by trying to first find the area of the triangle. So area is equal to AB over 2 times sine C. This is something of prior knowledge you should know from geometry class, or just this is something you should know beforehand from Heron's formula. So here we have sine C times AB over 2. Now we need to convert sine C. We're just going to rearrange this formula in such a way that we get Heron's formula now. So sine C can be replaced with the square root of 1 minus cosine squared theta, of cosine squared C. The reason for that is there is an identity which is sine squared theta plus cosine squared theta is equal to 1. And if you rearrange this, you get that sine squared theta is equal to 1 minus cosine squared theta. And then we can just square root both sides. And we get that sine of theta is going to equal the square root of 1 minus cosine squared theta. And that's where we're getting this in our equation here. So here we have 1 minus cosine squared theta. Now we're just going to substitute this even further. What we're going to do is use the law of cosines. And what the law of cosines basically says is that for side c squared, it is equal to a squared plus b squared minus 2ab cosine c. So we're going to use this, and we're going to rearrange this formula basically. Here, what we're doing is we're going to first bring we're just going to rearrange this, and how we're going to end up with this is cosine of c is equal to a squared plus b squared minus c squared over 2ab. Okay, so that's where we're getting this from. Now we're just going to continue on with our original problem here. So here we can just substitute 1 minus cosine squared theta. Basically just cosine squared theta. We're going to substitute, so we have, first we're going to write AB over 2. And we're just going to leave 1 minus, and then we're going to substitute cosine. So a squared plus b squared minus c squared over 2ab, and all of that will be squared. So here we have the next step, and that is going to be equal to the previous equation we had. Let's focus on this part a little bit more. Here, now it's just a matter of simplifying this even further. So we get our semi-perimeter in terms of S, basically. So next step, we're going to put the AB over 2 inside the square root symbol. So we're just going to square AB over 2. So we have a squared b squared over 4 times 1 minus a squared plus b squared minus c squared over 2ab whole squared. Okay, so I hope you all are track so far. Otherwise, what I said at the beginning of the video still applies, and I will hit you with the chuckle. Anyway, here we have a squared b squared over 4. Now we just need to put that into our actual equation here. So one thing we need to do is we need to square this part of the square root. So what we're going to do here is a squared b squared over 4 times 1 minus. So we have to we're going to keep the numerator inside the inside the square root. We're going to keep that under the square root, but we're going to square the bottom part of the radical. So how this is going to help exactly, I'll scroll down a bit and we'll see this right now. So here I basically wrote everything out for you. So what we're doing here is basically multiplying all this out, and when we multiply it out, it all simplifies to this radical over here, 4a squared b squared minus a squared plus b squared minus c squared whole squared over 16. You can just get this from simplifying this above part over here. So when we continue with this, what we're going to do now is we are going to do some factoring. And well, how we're going to do that? Well, this is a difference of squares, so we can just use that as our first step. So 2ab plus all of this in the parentheses, so a squared plus b squared minus c squared times 2ab minus all of that, so minus a squared minus b squared plus c squared. And we get all of that, and it's all going to be over 16. So let's have all of this room in order to fully factor this out in order to get the final result. Here we will now see that a squared plus 2ab plus b squared, that's just equal to a plus b squared, right? So we have a plus b squared minus c squared inside this parentheses, and here we can just use the same logic. What we're going to do is c squared minus a plus b squared. Notice that a minus b squared, I'm sorry. So a minus b squared. Here, that would be because the a squared and b squared are negative. So we first need to put a negative sign in front to make this statement true. So here after that, we would simplify this even further by getting that now a plus b plus c times a plus b minus c times b plus c minus a times a plus c minus b. Basically factoring everything out. And we get this. So now we know that 16 is also equal to 2 to the 4th power. So basically, if I can write this 16, I can separate all of these fractions out. And what I get here is that a plus b plus c over 2 times a plus b minus c over 2 times b plus c minus a over 2 times a plus c minus b over 2. That's just an equivalent fraction you can get there. And finally, what we're going to do is, if you notice, a plus b plus c over 2 is equal to s. That's the semi-perimeter. So we get s for that. A plus b minus c, that is going to equal s minus c, right? We can just rearrange this to match our letter order. So s minus a times s minus b times s minus c. And how I'm getting this is that a plus b plus c is going to equal, over 2 is going to equal your semi-perimeter. Now, out of that semi-perimeter, you're subtracting that c out, Okay, you're subtracting the A, B, or C out in 1, 2, or 3 cases. So you're basically just doing when you do that, you're getting this as a result of that. So that is the proof for Heron's formula. Hope you all enjoyed, and I expect you to be coming back to watch the next video. Please leave any suggestions or in the comments below, and like and subscribe to this channel. Thank you, and hope to see you in the next video.